The 2025 Nobel Prize in Physics goes against everything we've ever thought, and it becomes increasingly more crazy when we dive deeper. So, buckle up, because the things talked about in this video are so amazing that you might never look at the world the same again. Alright, so the 2025 Nobel Prize for Physics was awarded to John Clark, Michael H. DeVore, and John M. Martinez for their work on quantum tunneling. They had actually done this work in the 1980s, and it might completely shock you. Okay, so first, let's talk about electrons. When we observe them, they are particles that we can see, but otherwise, the electron is actually a cloud of probability around an atom and collapses when we observe them. This cloud can be described as a wave function. This wave function shows us the probability of the electron being at some place. Now, the electron wave function accounts for the entirety of the possibilities, and the electrostatic force that exists creates a sort of wall around the electron. However, this wave function does not end where the electrostatic attraction is enough to hold the energy of the electron. The electron actually has a small chance to appear outside of this cloud. So how does this help us? These researchers set up an experiment. They cooled a superconducting circuit with a Josephson junction to near absolute zero so that billions of electrons merged into a single coherent quantum state, turning the entire electrical circuit into one quantum object. Classical physics said that this system should remain trapped in a stable energy state unless enough energy is added. But this experiment showed something impossible by classic rules. The whole circuit abruptly switched states by quantum tunneling, even though it did not have the energy to cross a barrier. At the same time, the circuit could only occupy discrete energy levels, proving that energy was quantized. This was the first direct experimental evidence that quantum mechanics applies not just to small particles, but to macroscopic, human-sized systems. This amazing experiment showed us that items at a macroscopic level don't behave classically, and it set the foundation for modern superconducting technology, and is used extensively in quantum applications. This experiment shows us that quantum tunneling is possible at a macroscopic level, changing everything we've ever known. Well, why did they win this Nobel Prize in 2025 and not in 1985 then? That's because this experiment was way ahead of its time, and they didn't have the technology to use this data. However, now, this knowledge has been extensively used in tech like superconducting quantum computers. This is one of the most interesting experiments I've ever heard of, and this Nobel Prize helps us acknowledge these scientists' achievements, which is well deserved. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye!